Hello everyone, how are you? I am Akrash, your teacher here, and I will teach you different questions and their answers. So I welcome you on classtheta.com. So our today's question is curve evaluation. Study the snake code in UNR web campus and correlate it with the derivations shown in the class experiment with the initial conditions shown in panel 1 and report results. The matlab code for initialization is provided. You need to make the synthetic image in each case clearly show initial and final state of the curve evaluation. B. Now use the code for Chan-Vese active counters without the edges by having many circles on the images and show the revolution. Apply Chan-VeseCurve evaluation. A. Study the snake code in UNR web campus and correlate it with the derivations shown in the class experiment with the initial condition shown in panel 1 and report results. The matlab code for initialization is provided. You need to make the synthetic image in each case clearly show initial and final state of the curve evolution. P. Now use the code for Chan-Vese active contours without edges by having many circles on the images and shown the evolution. C. Apply Chan-Vese. And the answer of the question is, it seems like you are asking for guidance on how to approach the task related to curve evolution, specifically using snake and Chan-Vese's active contour models in matlab. Here is a structured approach to address each part of your query. Part A, snake model. First, student snake code derivations. Access the snake code provided on UNR web campus and review the derivations shown in the class. Understand how the snake model is implemented and its mathematical basis. Second, experimental with initial conditions. Use the matlab code provided for initializations to create a synthetic image. Implement the snake algorithm with the various initial conditions as shown in panel 1 of your assignment or as per your experiment setup. Third, report results. Execute the snake algorithm with different initial conditions. Capture and document the initial and final states of curve evolution for each experiment. Clearly present these results possibly through visualizations showing the evolution of curve over iterations. Part B, Chan-Vese active contours without edges. 1. Implement Chan-Vese active contours. Modify the Chan-Vese active contours code to work without edges, focusing on regions represented by many circles in the images. This typically involves adopting the energy function and segmentation approach to identify and segment regions based on internal characteristics rather than edges. Shown evolution. Apply the modified Chan-Vese algorithm to your image containing multiple circles or circular region. Visualize and document the evolution of the contour over time as the algorithm iterates. Part C, apply Chan-Vese. First, apply Chan-Vese algorithm. Implement the Chan-Vese active contour model using the standard approach, considering both inside and outside region based on image characteristics. Second, report findings. Execute the Chan-Vese algorithm on your synthetic images or images with circle. Present the initial and final state of the curve evolution. Discuss and analyze the effectiveness of Chan-Vese or segmenting circular regions compared to the snake model. General advice: matlab implementation. Ensure you understand the matlab syntax and function necessary for image processing and curve evolution algorithm. Use the matlab's image processing toolbox if available. Documentation: clearly document your approach including code comments and explanation of parameters, choice and interpretation of result. Visualization use matlab plotting capabilities to visualize synthetic images, initializations, and final contour states effectively. Correlation with theory relates your experimental result back to the theoretical derivation. The concept discussed in your class or in the provided materials. By following these steps, you should be able to effectively complete the task related to curve evolutions using snake and Chan-Vese models in MATLAB as outlined in your assignment. Thank you for watching the video. If you have any question related to this video, please post a comment below. If you have any question in your mind, you can also post on the website and I will be answering you in the next video. Thank you for engaging with us. Until next video, bye bye.